Yaskawa. You are watching the PLCopen Part 4 Coordinated Motion video tutorial series. This video shows how to program coordinated linear moves. Hi, I'm Matt Pelletier. Here's a quick preview of what's to come. To trace out this triangular path, use the function block mc_move_linear_absolute. The coordinate positions are entered as a vector data type, and be sure that the axis 0 points are established and the group is enabled before executing the move sequence. To follow along in this tutorial, you need the class project PLC04 training with the group configured for a 2D gantry as shown in the previous video. Be sure you're running MotionWorks IEC Pro version 3.2 or higher, and while you can do a lot of this offline, to test out the motion you'll need the MP3300 IEC demo with this project running on it and the controller firmware at version 3.2 or higher. If you would like remote access to an MP3300 IEC and Sigma 7 demo, please request by email to training@yaskawa.com. You can see how this works in the remote connection e-learning video. The required motion for our gantry in this example is to trace out this triangular path from point A to point B and stopping in between, then from point B to point C, and finally from point C to point A. So let's assume that the system starts at point A, and let's jump right into the program. Let's insert a new program POU for this, and we'll name it linear with the ladder diagram language. And before I forget, let's run that in the fast task. I can right click to insert the program instance, linear. Then I'll go back up here and open up this worksheet. The main block of interest will be found in the group called PLCopen Part 4, mc_move_linear_absolute. Drag that one in here. You notice there is also mc_move_linear_relative, but usually absolute makes it easier just to enter the coordinate points rather than calculating the difference in position. So first up is this axis group. Of course, it's good practice to open up the help on this block. An axis group is looking for an axis group ref data type. And in the last video, the configuration created a variable with this data type. It's the one that we had named called gantry xy. So we'll go to this and enter gantry xy. Let's give it a ladder contact to execute with. Call it start move and leave it as a local var. So how about position? Do alt arrow back to look at that. Position is a vector data type, and this is an array that allows us to enter the positions of the Cartesian coordinate space. So we'll just create a new position and we'll call it, well, our first point will be point B because we're already at point A, so I'll call it point_B, data type vector, usage var. And we can put in those coordinates 90 and 180 for x and y. One way to do that is to find that variable in the variable list and view the initialize multi-element variable window. And here we can see all of the elements of this array. We'll just be using x and y, which are number 1 and number 2. This is an L real, so we'll put in 90.0 and 180.0. I'll close that to free up some space and get back here again. Now velocity, XL, decel, these are all L real values in the user units that we already have set up. I'll call velocity path speed. And let's use slow values so that it's easy to see this through the video screen. How about 25.0? Now for acceleration, I'll call that one path ac dec. And let's take a slow acceleration of 100.0. Copy that one over to the deceleration. And the rest of these inputs can be left blank. We'll look at some of them in the next video. But that only takes care of one of these three moves from A to B. We still need to move from B to C and from C to A. So let's sequence those three moves together. And there's a couple ways you can do this. One would be to just change this point B coordinates live and we could then re-execute this move linear absolute. That can work well when you have a lot of points. However, in this case, we have just 3 points. I think it makes more sense to simply add a couple more move linear absolutes and sequence those together. Using the done output, I'll call this one done underscore B. And now we can proceed to sequence these. MC move linear absolute. Number 2, gantry XY. We'll execute it with done B. Done B. And this will go to point C. Point underscore C. I'll just copy the speed XL and decel with control click. And now one more for point A. MC move linear absolute. Gantry XY. This one will be triggered by done C. So I'll need to make a done C here. Done C. And again, we'll use control click to spawn off a copy here. And I need to make point underscore A. And that about does it for the move sequence. But the move sequence is not the only thing that's important here. It's important that 3 things be done ahead of time. One is that the 0 point has been calibrated for the system. The second is that the servos have all been turned on. And the third is that the group itself has been enabled. When those 3 things are done, we'll call that group ready. So make a new variable for group ready. And above here, let's test each of those conditions. We said there were 3 conditions. One was that we have group power. Another was that we have group 0 done. And the third is that the group is enabled. When those 3 things happen, the group is ready. So let me insert a few rows here with control 1. And first I'll tackle group enabled. Group enabled comes from this function block, MC group enable. When the group is enabled, then you don't have individual control over the axes anymore. They are now functioning as a team, as a group. This is the gantry XY. And when this is done, the group is enabled. All right, so let's give a command to enable this group. We'll call that enable group. And let's be sure the servos are on before we try to enable this group. That can be done with checking for group power. So how can we find group power if the servos are on or not? This has already been programmed for us in the controls POU. This is where we're turning the servos on. And the variables are called x-axis.status, y-axis.status. So let's make a rung here for x-axis.status. Another contact for y-axis.status. If both of those servos are on, then the group has power. So we have group power, group enabled, but we don't have group 0 yet. So I'll add one more ladder rung here to give us the condition for group 0 done. This functionality exists in the project under the home POU, where we set the axes and we set this bit here x-axis.home.homed. So similar to the group power, we'll do that x-axis.home.homed, and also a second one for y-axis.home.homed. And so I think this gives us some good solid logic here to be sure that this group is ready before we attempt to do any of these coordinated moves. Okay, let's test this out with a make of the project. I have 0 errors. I've got the demo connected. Now under online project control, I can download and warm start. I'll close the resource and go to online debug. And you can see here, none of my conditions are met yet. So over to the HMI POU, I'll turn on toggle Boolean under the online menu, toggle Boolean. And I'll click to turn on servos X and servo Y. Back in linear, you can see that that has been recognized. And in the HMI POU, let's go down to rung number 6 again. And I'm pretty close to 0, but you could dial those in and try to get the motors as close as you can to mechanical 0. Down at rung 13, you can set that 0 point. 0 set. And the watch window confirms that the positions are very near 0. And back in our POU linear, that shows that group 0 is done. So all that's left now is to enable the group. So let's enable the group. And now the group is ready. But before I start the motion, I want to show that back in the HMI POU, on rung 6, you could attempt to jog one of these servos or use any single axis motion block, and the motor won't move, it won't jog. But not only won't they jog, you can open up the manual POU, which has the jog block, and you'll see there's even an error why they're not able to jog, 4370. And one of the reasons for error 4370 is that if this axis is included in a grouped axis, the error may occur when you're executing a single axis function block, and that's what we're doing. So if you need to jog a single axis again, you've got to get it out of group mode, and that would be done with the group disable function block. Let's stop the jog and continue. Before we start this move, I think it's a good idea to add these points to the watch page. Let's use watch page number 2. Add point B. Add point C. And right click to add point A. Let's check these out. Point B is at 9180 because we initialized that one. Point C should be at 180.0. It's not, so let's update that. 180.0. Overwrite. And point A is at 00. So we're good there. And I think we should also add, for completeness, the gantry group variable to the watch window. See all the data that's in this variable. And one of them is pretty important, I think I'll add it separately, is the machine actual position. And array element 1 will be for the X. See, that's at 0 as expected. Let's add it again. The machine actual position array element 2 will be Y. Right now, those match the direct read axis positions. But one difference is that this is only updated when the group is enabled. Now let's try this out in the demo, keeping an eye on the actual position, both in the watch window and on the demo itself. And let's start the move. Click overwrite. For just moving to point B at 90/180. Now it's done and moving off to point C at 180.0. And now the final move back to 00, which is point A. And the coordinated linear move sequence is complete. All right, let's finish this off by leaving debug mode and saving off this project as a zip at the stage that we're at. And I'll call it PLC04_linear. Thank you for watching this video, and remember, Yaskawa.com/IEC is the starting point for everything related to the MPIEC controllers and MotionWorks IEC.